Good morning, folks. So we are finishing up the last little bit of topics for matrices today. And although there's a lot of application to this chapter, I wanted to do something a little bit outside of the box as a nice culminating connection here. So today we are entering the spy world. We are going to learn how to code and decode messages using these matrices. It shouldn't be too surprising that matrices, as complicated as something simple like multiplication looks in the world of matrices, that complicated process is to our advantage when we're dealing with security, when we're dealing with coding. You want something to be very complicated when coding a message because it shouldn't be very easy to decode. So this is my secret message. I am now a spy, and I'm going to talk to my fellow spy, and I'm going to send them the message, meet me at the library. So it would make sense that I don't want to just let this message go out into the world because it's going to be, secret, it's secure. So we need to code this in a way that if it fell into the wrong hands, the message would be very difficult to interpret and it would be meaningless unless you were privileged to the method of decoding this message. So what we do is we have 5 different groups of letters. Each one of those groups is going to become a 2 by 2 matrix. So like the first one, M, E, E, T, like that would be the first word uh, in terms of our secret message there. And then what we do is each letter gets corresponded with a number because obviously we don't want to work with letters, we want to do with numbers. So MEET becomes 13, 5, 5, 20. And we see each of the other pairs of matrices become these next 4 2 by 2 matrices. Now keep in mind those 2 Q's at the end, those were just filler because we didn't have enough letters to fill the last one. So if you ever have a message that you're going to be using, just fill it in with whatever blank letters you want. Now, this is already pretty secure. It's coded, but notice all the numbers are between 1 and 26. So at a quick glance, a spy would look at this and say, I wonder if those numbers correspond to letters. And it would be probably very easy to backtrack and figure out your message. So we want to go further. We want to make this more secure. So that's where we use something called a cipher. A cipher is kind of like the scrambling mechanism that we're going to use. And a cipher is just a simple 2 by 2 matrix. All we need to do is we're going to take our cipher and we're going to multiply it to each one of these matrices. And you already know from doing this for the homework earlier in the week, multiplying a matrix by another matrix results in something that you would be very hard to predict the answer. So taking this cipher matrix 2, 1, 5, 3, I'm going to now take my first 2 by 2 matrix. This is the original coded message. I'm going to multiply it on the left side by my cipher. And this here would be the coded message that then I send out to hopefully get received by my colleague. And then this would be just another example. This would be the next matrix. So this was the secret code for the word meet. This is the secret code for the words me at. And you would keep going on multiplying the cipher to the original message, and you get something completely different looking that you wouldn't expect. So this here is the series of coded messages. So this is actually very well coded because you have numbers that at quick glance don't look like any pattern, don't look like any significance, and you have something as small as 5 and as something as large as 176. So even the number spans that they have are very hard to interpret meaning for. So even if this did fall into the wrong hands, it would be protected in the sense that it'd be very difficult to break the code here. So assume for a moment that my message, after I sent it, it did reach my colleague. So now my colleague doesn't know what this message means either. So they need to do the decoding on their end of the thing. So they would probably have the same cipher matrix that I used uh, to code, and it should hopefully be pretty intuitive. If I am coding with a cipher, you're going to use an inverse of that to decode a message. Okay? And you all know from yesterday's lesson that this is the inverse of my cipher. And I'll even say cipher inverse, little -1's notation. Okay? So you would have to do a quick little computation, figure out what the inverse matrix is, and then just like we coded, we're going to decode by multiplying through by the inverse. Because we coded on the left side, we're going to decode on the left side here. And when you multiply through by that inverse, it undoes all of the operations we saw, and we're back at the original message that I coded. So 135520, we would then go back and say, okay, 13 is M, 5 is E, 20 is T. There's the first word of the code. And you would continue decoding the other 4 remaining matrices. So what I have planned for you is, if you check out the Google form, I already coded a message and I gave you the cipher I used to code the message. Your task today is decode my message and send me back what the original message is. And I'm going to use this same alphabet. So A is 1, B is 2, all the way up to Z is 26. So when you get your final numbers, you have to go back to the alphabet in order to decode the final message. Okay? Keep in mind, that's task 1. Task 2 is on the course page post. There is a set of problems from the textbook. I want you to write those problems out and take a picture of your work and submit that to me. So that is going to be your graded task for the week, as long as you get it to me by the end of the day on Friday. So even if you run out of time today, you'll have all day tomorrow to finish it as well. I'm not going to give you any new lessons or tasks tomorrow on top of this. So if you have questions, let me know. If you're confused, let me know. If you have concerns, let me know. Otherwise, good luck decoding and good luck with getting the work done.